Okay, the motion of a North Pole magnet above the page, right? So the magnet is going to either approach or recede. So let's figure out the direction first, because I imagine that's what you have a question about, right? So it's a North Pole magnet. So let's draw this, right? North pole's down, South pole's up. Here's the page, right? The magnet is either approaching or receding. Okay, now we know that the current flows clockwise in the loop, right? So it's going to go clockwise in this page. So as you look down on this page, it's going the way of the clock. It's going this way, right? So take your hand, take your right hand, wrap your fingers of your right hand, wrap your fingers that way, and notice now that the North Pole is facing down into the page of this magnet, and the South Pole is facing up. It's a South Pole facing up, right? So we now know the answer. Okay, this North Pole is trying to escape. Okay, why? Well, because the induced current always opposes the motion of the magnet. Okay, always opposes the motion of the magnet. So if the North Pole is trying to get away, it makes sense that you'd present a South Pole to it, right? Now we know there's a South Pole being presented to it because it's clockwise, right? So therefore we know that it's trying to get away. Okay, we have to make it work, because this could light up a light bulb. Moving that magnet away, this must do work to generate power in the loop. How's that? All right. Okay, so we now know that it's receding. The magnet tried to recede. Okay, so now you darn receding magnet. All right, so let's see it. Motion changes. Okay. So how large was the change in magnetic field? That's what we're trying to find. Okay, so we're going to go EMF is NBA over T, right? 3.4 amps flows clockwise in the loop. Okay, so my EMF, V is IR, right? So my EMF is 3.4 amps times 0.53 ohms, right? Let's figure that out. 3.4 times 0.53. That's 1.802, right? Volts, and now we're all set. So let's go 1.802 volts is equal to, there's only one winding, right? The change in B is what we're trying to find, right? The area is 0.63 squared, because it's a square, right? And then how much time? 0.034 seconds. And we're just trying to find this change in magnetic field, right? So I'm going to take this number, the 1.802, I'm going to go times 0.034. I'm going to divide by 0.63 squared, and I should have the change in B. And I'm getting that the magnetic field, the absolute value of this, right, was 0.154. Now what's going on? Well, it's going, let's see, the change in magnetic field. It's getting weaker, right? The magnet's moving away, and so it's into the page, and it was strong into the page, and now it's less into the page. Okay? That's what's going on. A little crazy, huh?